go into serious depth on what mechanical tension precisely is later, but for now, think of it as the tension generated by a muscle's fibers. Does this fiber tension stimulate an increase in fiber size and subsequently whole muscle size? Intuitively it would, as if we substantially reduce the tension produced by muscle fibers, like done during immobilization or when in space, the whole muscle decreases in size. As early as the 1970s, researchers hypothesized both active and passive tension are stimulators of hypertrophy. Active tension is the actual contractile force produced by the muscle fibers, while passive tension is the force produced when the fibers and whole muscle are stretched. There were 4 types of studies linking active and passive tension to hypertrophy throughout the 1970s to 1990s. All of these studies were conducted on animals, and I want to preface this by saying I'm personally opposed to unnecessary animal studies, but as much as it's unfortunate to say, the following studies have all been pivotal in understanding muscle hypertrophy. The first type was studies that cut the tendon of usually the gastrocnemius, meaning this muscle could no longer carry out plantar flexion. This resulted in the supporting soleus muscle being overloaded and exposed to greater active tension during normal movement. In response to this, the studies consistently find the soleus experience substantial hypertrophy, therefore linking increased active tension to hypertrophy. The second type of study had a limb immobilized while the muscle was placed in a stretched or shortened position. These experiments find muscle size decreases a lot less when the muscle is immobilized at a stretched versus shortened position, therefore indirectly linking passive tension to being anabolic. The third type of study involved attaching weights to a wing of chickens to produce continuous stretching of their muscles. Doing so results in hypertrophy of the stretched muscles. Finally, the fourth type of study was virtually the same as the third, except it used a spring-loaded aluminium bar to stretch the muscles of chickens. Doing so again results in hypertrophy of the muscle. But if we carefully think about these 4 types of studies, and this was discussed in future research, none of them truly prove tension per se is stimulating hypertrophy. Could it not be the events before active tension, like the electrical signals, metabolite accumulation, or even damage, that is truly stimulating the hypertrophy in these studies? We'll thoroughly explore metabolite accumulation and damage soon, but the research in the last 20 years provides us with solid grounds to believe it is truly tension per se stimulating hypertrophy. A 2019 Danish study found that when inhibiting the active force generation from muscle fibers, but still allowing electrical signal input to them, activation of a key protein complex that signals muscle growth failed to occur. It was only when active force generation from muscle fibers was enabled did activation of the key protein complex happen. This suggests it is the active force from fibers that stimulates hypertrophy, not the electrical signals. The same researchers also established that when equating peak tension between eccentric contractions, which involved active and passive tension, and pure passive stretching, which would not involve active tension, only passive tension, activation of the key protein complex was the same. So this is evidence that it's total tension, regardless of whether it's active or passive, that stimulates hypertrophy. Another 2008 study out of the USA found that when keeping electrical input to a muscle constant, positioning the muscle at a length that allowed it to generate higher active forces resulted in greater activation of a key protein involved in signaling hypertrophy. So this study again demonstrates how it may indeed be tension per se that stimulates hypertrophy. A 2001 Canadian study found a linear relationship between peak tension and activation of a key protein involved in signaling hypertrophy. Finally, in the last 20 years or so, research is gradually accumulating on how precisely these forces can activate key proteins involved in hypertrophy. It turns out that within and around muscle fibers are mechanosensors that can detect active and/or passive tension, and then convert the tension into a signaling pathway that stimulates muscle hypertrophy. All of the key proteins explored in the previously mentioned studies are involved in the signaling pathways. We'll explore what these potential mechanosensors could be soon, but this overall evidence further strengthens the idea that tension per se is what stimulates hypertrophy. In humans, papers suggest that protocols that presumably involve higher mechanical tension results in greater muscle growth signaling and long-term muscle hypertrophy. Moreover, in human studies that presumably equate mechanical tension between different protocols, muscle growth signaling and long-term muscle hypertrophy tend to be the same. So it's clear solid research suggests mechanical tension is a powerful stimulator of muscle hypertrophy.